Let's begin with a clear picture of what the fine-tuning argument is actually claiming, and why so many people, physicists and philosophers across very different traditions, think it matters. Contemporary physics describes our universe by specifying both general laws and a handful of particular numbers: the strengths of the fundamental forces, the masses of elementary particles, the value of the cosmological constant, and certain initial conditions at the beginning of cosmic history. The striking fact is that life, any embodied, interacting, information-processing life, not merely carbon-based primates like us, seems to require those numbers and starting points to lie in astonishingly narrow ranges. Shift them slightly, and you get a cosmos with no stable atoms or chemistry, or one that races apart too fast for galaxies to form, or one that collapses into black holes almost immediately. This ensemble of facts is what people mean by fine-tuning. As one accessible overview puts it, the phenomenon emerged as physicists asked, what would have happened had the basic parameters been even a little different? Again and again, the answer was, no life of any conceivable kind could have arisen. So the term, fine-tuned for life, was adopted as shorthand for a universe that is fit for life, when modern physics shows it easily might not have been. Consider two prominent illustrations. First, the cosmological constant, which in Einstein's equations acts like a uniform energy density of empty space, must be extraordinarily small in absolute terms to allow structured complexity. Make it just a few orders of magnitude larger, and you get a featureless fog of diffuse gas with essentially no interactions. A universe with no meetings, no chemistry, no stars, no stories. Theoretical expectations place it vastly higher, which is precisely why physicists have long called it one of the most severe fine-tuning cases. When critics object that perhaps the life-permitting window is wider than enthusiasts say, even sympathetic reassessments concede that, whatever the exact width, the value still must be unnaturally small relative to natural physical scales. Fine-tuning at the level of ratios remains. Second, step back to the initial entropy, the universe's primordial orderliness. On standard measures, the Big Bang had to begin in an extraordinarily low entropy state to yield a cosmos in which long-lived stars, complex chemistry, and biological evolution are even possible. Roger Penrose famously estimated the improbability of a comparably smooth start at around 1 part in 10 to the power of 10 to the power of 123p. A number so huge that writing it out would require far more particles than the observable universe contains. Even popular scientific treatments emphasize that, however one tidies up the technicalities, the initial state embodies a truly astonishing amount of order, and the question, why, does not go away. So how could such facts bear on the existence of God? One rigorous way of framing the inference is Bayesian. Ask whether the data D that the universe is life-permitting against long odds are more expected if theism T is true than if a rival hypothesis N, say single universe naturalism, is true. In Bayes' theorem, evidence supports a hypothesis to the extent that it was antecedently likelier on that hypothesis than on the alternative. Philosophers who develop the argument in this way, following discussions of design by Swinburne and others, use Bayes to capture the intuitive thought. If a mind with reason and value sensitivity had reasons to bring about creatures capable of knowledge and love, then a life-friendly cosmos is not surprising under T, by contrast under N. Where the numbers are what they are for no purpose, a life-friendly outcome looks like an enormous stroke of luck. The formal moral is simple. If P D greater than P dN, then observing D raises the probability of T relative to N. It's crucial that support here doesn't mean certainty. It means incremental confirmation, an increase in rational credence given the total evidence. That is why several philosophers explicitly describe fine-tuning as a C-inductive argument, one that adds weight to theism rather than purporting to prove it. To keep our reasoning as clean as possible, let's make the core comparison crisp. The single universe naturalism hypothesis says, roughly, that there is just the physical universe, governed by indifferent laws. The theistic hypothesis says there is a supremely intelligent and good personal reality that freely creates and can act to realize worthwhile goods through nature. Our background knowledge includes the basic deliverances of modern physics and cosmology, laws, parameters, and the empirical fact that many small changes would have obliterated the possibility of life. On that background, the fine-tuning datum is that those parameters and initial conditions do, in fact, fall in the narrow, life-friendly ranges. A careful survey of the literature frames this datum in just those terms. A short list of parameters with very precise actual values, small deviations would render life impossible. And this assembly of coincidences is astronomically improbable on chance. When we ask which hypothesis better expected such a world, the theistic hypothesis has a ready explanatory pattern: intention tracking objective goods. The naturalistic single universe hypothesis must treat it as brute. That asymmetry is precisely the Bayesian engine. I got. Because philosophy is a contact sport, objections arrive quickly. One family of objections tries to show that the probabilities the argument needs are illegitimate or inscrutable. Another contends that future physics will remove the arbitrariness by deriving the constants from deeper laws. No free parameters, no fine-tuning problem. Another appeals to a multiverse. If reality contains countless domains with varied constants, then it isn't surprising that somewhere a life-friendly pocket appears, and of course we find ourselves in it, rather than in one of the lifeless wastelands. Let's take these in turn. Not to neutralize criticism with rhetoric, but to ask what survives under pressure and what needs refinement. First, the worry about probabilities. You can't assign measures over infinite ranges of constants, or you can't say how likely any particular constant is. The literature is explicit that this is a serious technical challenge, the so-called normalizability problem. But it is not unique to the argument for theism. It haunts any attempt to assess how surprising our world is given different physical possibilities. What recent formulations do is shift the focus from speculative probability distributions over all possible worlds to probabilities physics itself supplies for concrete explanatory tasks, the little questions we can actually pose and answer. The strategy is to ask, within real physical models we use and test, for the relative measures of life-permitting versus life-forbidding ranges, using the ways practicing physicists already quantify sensitivity to parameters. That keeps the inference tied to the discipline rather than to armchair measures over metaphysical spaces. Second, future physics. Suppose deeper laws fix the values of the constants. No more free knobs to twiddle. Wouldn't that dissolve the appearance of contingency and, with it, the probative force of fine-tuning? A nuanced reply is that the big question simply moves up a level. If there is a final theory with zero free parameters, we can no longer run the vary the constants thought experiment. But we can still ask whether that elegant final system, those exact equations and symmetries, was to be expected on bare naturalism. If most mathematically possible laws and initial states would not allow life, then the new question is whether the actual laws we discover, life-friendly and all, are more to be expected under theism or under naturalism. In other words, explaining away sensitivity at one level doesn't collapse the inference. It reframes it at the level of why this life-friendly law structure, rather than a simplicity comparable one, that is sterile. Third, the multiverse. The idea is elegant. With sufficient variety and number, even a tiny life-friendly window will get hit somewhere, and only there will observers arise to notice. So fine-tuning ceases to be surprising. This proposal is fascinating and, in some forms, motivated by independent physics, e.g., some readings of inflation. But it is not the end of the discussion. One thing critics emphasize is testability. If the mechanism that generates the multiverse, say inflating regions spawning pocket universes with differing low-energy constants, lies in principle beyond adequate empirical testing, then the move from fine-tuning to a multiverse risks replacing one explanatory mystery with a metaphysical promissory note. Other defenders reply that indirect tests or theoretical virtues can still do real work. More importantly, for our inference, even if a multiverse exists, the Bayesian question persists. What is the probability on the relevant hypothesis that a multiverse-producing physics would obtain, and, within it, that observer containing domains would be realized? Theism can, in principle, be open to either a single cosmos or a multiverse, depending on which better serves the realization of value. A naturalistic multiverse needs to be justified by physics rather than invoked ad hoc. And even enthusiastic surveys of possible wider windows concede that parameters must still sit at unnaturally small values relative to fundamental scales. Fine-tuning in a multiverse remains fine-tuning locally. Another objection is sociological rather than technical. God wouldn't fine-tune. Why make a universe that needs such delicate balancing? Here it helps to distinguish two claims. One is an aesthetic guess about divine preferences. The other is a modal claim that God could have chosen differently. The Bayesian argument doesn't require that God must fine-tune. It requires only that a life-friendly cosmos is not surprising on theism. If realizing finite rational agents and histories of moral significance requires physics within a certain range, then fine-tuning is simply the way in which the more basic good is secured through the medium of nature. Contemporary formulations explicitly address this. The datum is not a taste for fiddly numbers. It is that the actual world is life-permitting in ways antecedently unsurprising given theistic reason. A different pushback insists the appearance of fine-tuning is illusory because we're committing an observation-selection fallacy. Of course we observe a life-friendly universe. We couldn't be around to observe otherwise. But selection effects by themselves don't explain why there is something to be selected. It is one thing to note that observers will only ever find themselves where observation is possible. It is another to explain why the underlying ensemble, single or multiple, contains observer-possible regions at all, and why their preconditions are met. The standard way to avoid the inverse gambler's fallacy is to combine selection effects with an independently motivated ensemble that actually makes the life-friendly outcome not insanely rare. Absent that, the surprise persists. Accessible discussions of anthropic reasoning emphasize exactly this. Saying we could only observe such a universe does not, by itself, erase the need for an account of why such universes exist. Let's come back down from the dialectical high ground to the concrete physics, because that is where the intuitive force of the argument lies. The cosmological constant case is a useful bellwether. Widely separated lines of thought converge on the judgment that even modestly larger values suppress structure formation. Likewise, realistic treatments of entropy stress that low-entropy beginnings are precisely what give the cosmos the free energy gradient for complexity to emerge. Without it, the universe either smears into equilibrium heat death or never forms long-lived stars. Even authors cautious about how to present Penrose's gargantuan number emphasize that the sheer quantity of cosmic order, far beyond what is parochially needed for us right here, is hard to believe, is purely the result of chance. Summaries aimed at non-specialists reinforce the same pattern by way of examples. Nudge the cosmological constant the wrong way, and either everything flies apart too fast or collapses at once, forestalling life entirely. Similar sensitivity obtains for parameters governing nuclear synthesis, radiation backgrounds, and the stability of complex atoms. Do these considerations amount to a demonstrative proof of God? No, they were never supposed to. What they do, when carefully framed, is render theism a better explanation, all else equal, of a striking and otherwise very surprising feature of our world, that the fundamental setup of the cosmos sits on a razor's edge for the possibility of life. That is why even writers who are critical of specific derivations or of oversold rhetoric still take the question seriously, and why comprehensive surveys treat fine-tuning as a locus where physics, philosophy, and theology meet, rather than as a quirk to be waved away. It is also why more technical critics, those who press Bayesian formalities hard, aim not at dismissing the phenomenon, but at disputing whether certain probabilistic versions single out traditional theism uniquely, or rely on contestable value assumptions in assessing priors. Those are exactly the right places to press. They invite us to refine the hypothesis space and to articulate, with as much discipline as we can, the comparative expectations of rival worldviews. At this point, some listeners from secular traditions ask a fair question. Even if fine-tuning supports design in some abstract sense, why think it supports the God of any living religious tradition rather than a deistic architect, a committee of demiurges, or a life-generating computer in a parent universe? The short answer is that fine-tuning by itself cannot uniquely identify a tradition. Its natural role is cumulative. It contributes a real evidential increment toward a mind behind cosmic order. Other considerations? Metaphysical arguments about the ultimate explanation of contingent reality, questions about consciousness and value, historical or experiential claims, may then interact with this increment to sharpen the identity of the designer. In Bayesian terms, fine-tuning belongs in the evidence set, alongside other data. Formal critics of Swinburne are explicit that the move from some designer to traditional theism requires additional premises and is precisely where much of the philosophical work lies. What if, in the end, the best physics tells a story in which fine-tuning is explained by a multiverse grounded in elegant test-constrained theories? Then the evidential balance will shift, perhaps toward a theism that appreciates providence working through ensembles, perhaps toward a chastened naturalism that still must account for why the ensemble exists with the right generative properties, perhaps toward a new synthesis we cannot yet see. Either way, the thing to notice is that fine-tuning does not go away merely by saying many universes. It moves the why from local outcomes to the metastructure that makes life-friendly domains, likely enough to expect observers somewhere. Even proponents of such scenarios leave the central tension in view. Our best confirmed physics ties complexity to exquisitely constrained boundary conditions and parameters. Absent an independently warranted mechanism to populate the right parameter ranges, the surprise remains, and with it, the explanatory pull of mind. So here is a way to summarize the case without polemic. Start from what the physics is telling us. Many small changes would have made a dead universe. That is not rhetoric, but the content of detailed models. Ask what sort of hypothesis would make that less surprising. A theistic hypothesis, under which the realization of finite rational goods is a central aim, makes a life-friendly setup antecedently plausible. A single-universe naturalism gives us no comparable reason to expect it, and so is forced to eat the improbabilities as brute fact. A multiverse makes progress only if anchored by independent physics that genuinely raises the expectation of observer-contemplating domains. On those comparisons, fine-tuning is evidence for God, not a knockdown proof, but the right kind of cumulative indicator of mind behind the cosmos. If you're listening from within a Christian, Islamic, Jewish, or other theistic tradition, you might hear the cadence of ancient claims in new scientific dress. The heavens declare the glory of God. Would on this constrol be updated to, the deep structure of the cosmos declares the intelligibility of reason-guided creation. If you're listening from a secular position, you might still grant the modest moral, whatever else we say, our place in reality is remarkable, and that remarkable fact is more at home in some worldviews than in others. Either way, the argument invites a very human response. Gratitude, curiosity, and the resolve to keep asking the next better question, both of physics and of philosophy. And that is, I think, one of the wisest uses of an hour spent together. Before we press on to further case studies, nuclear resonance levels for carbon and oxygen, the amplitude of primordial fluctuations, the running of coupling constants, and then to a sustained engagement with the multiverse literature. Let me leave you with a thought experiment. Imagine a vast radio with countless dials, most positions yielding only static. The surprise in our world isn't that someone hears music somewhere. Someone would, if the studio exists. The surprise is that the dial is already set to a station that carries a long symphony capable of supporting listeners, performers, traditions, and critique. The fine-tuning argument says, on some hypotheses, that is exactly the sort of thing we should expect to find. On others, it is astonishing good luck. And the way rational agents respond to astonishing luck is not by declaring nothing to see here, but by asking whether there is a better explanation. One that treats the music not as accident, but as intention, articulated in law and number. If you've ever heard the phrase, "we are stardust," the fine-tuning conversation starts right there, in the belly of stars where carbon and oxygen are forged. There's a now classic story about how carbon gets made. 3 helium nuclei, the little alpha particles, have to come together in a 2-step dance. 2 collide to form a very short-lived beryllium-8, and before that decays, a 3rd helium has to hit just right to make carbon-12. For that second step to be efficient enough in real stars, nature seems to have given us a resonance, a special energy level in the carbon nucleus, the so-called Hoyle state, sitting at about 7.65 MeV. That resonance is not a vague miracle story. It's a well-studied, measurable nuclear feature that enhances the reaction rate by orders of magnitude. And if you alter the strengths of the strong nuclear force even modestly, the energy of that state shifts, drastically changing how much carbon and oxygen the cosmos can cook. Carbon is the backbone of complex chemistry. Oxygen is the workhorse of water and metabolism. If either is severely suppressed, you don't get anything like the biochemical versatility life exploits. And that is why many researchers describe the relevant couplings as fine-tuned for this resonance's placement. The technical literature says it plainly. The strength of the nuclear force appears tuned, so this 12C state lands at just the right energy to enable abundant carbon through the triple AIMA process. Once you have the carbon story in mind, notice the pattern. Life-permitting outcomes often ride on features of physics that didn't have to be the way they are, at least not according to our best current theories. When Luke Barnes surveyed the field, he assembled case studies that range from stellar structure to galaxy formation to the stability of atoms, and the theme is that the range of parameters that permit intelligent life is tiny in comparison to the broader spaces our theories naturally describe. That conclusion is not a devotional claim. It is an attempt to summarize what you see when you systematically vary constants in the relevant equations and watch the consequences. Barnes's review has become a go-to reference precisely because it catalogs those sensitivities while engaging skeptics and objections in detail. Now, let's talk entropy and arrows of time, because this one is both conceptually deep and viscerally striking. Our universe began in a state of ridiculously low entropy, ridiculously ordered compared to the vast majority of physically allowed states. That low entropy beginning is what gives us a thermodynamic arrow of time, free energy gradients, and, downstream, the possibility of long-lived stars, complex chemistry, and life. Roger Penrose tried to quantify just how special that beginning would have to be if you picked a state at random from the space of all possibilities, and he reached a number so mind-boggling that it has become a symbol in these debates. Roughly 1 part in 10 to the power of 10 to the power of 123. Even if you bracket the derivation and refuse to fetishize the exact exponent, the moral stands. The initial condition is extraordinarily special in a way that cries out for explanation. You can feel the dialectic now. If you step back and ask, what hypothesis would find carbon and oxygen-friendly nuclei, life-supporting chemistry, structure formation, and a low entropy beginning unsurprising? The theistic hypothesis has a ready response. A rational, value-responsive idea? A rational, value-responsive ideal of knowledge and love will predictably arrange the deep preconditions that make those goods realizable through natural processes. By contrast, an austere single-universe naturalism has to treat the conjunction of all these thin slivers as brute, a cosmic coincidence that just happened to happen. Bayesianly, that's the whole game. if the probability of a life-permitting ensemble of constants and initial conditions is substantially higher given theories, that is not a proof. It's a comparative expectation claim dressed in the formalism that every empirical science already uses when it updates hypotheses in light of data. But a good critic will immediately press, are those slivers really so thin? Or are we exaggerating the sensitivity because we're exploring a cartoon version of parameter space? This is why concrete examples matter. Take the cosmological constant again, the parameter that controls the accelerated expansion of space. Crank it up even a bit above its tiny observed value, and you blow apart structure formation. No galaxies, no long-lived stars, no chemistry of any interest. The basic point appears across many independent lines of modeling. Modest increases wash out the density fluctuations before gravity can do its sculpting work. That is one reason the cosmological constant has been called the most extreme case of apparent fine-tuning in physics. A neutral, technical review will tell you this in a sentence that sounds dry, but you should hear the astonishment in it. The value is extraordinarily small in natural units, yet non-zero. And had it been larger by orders of magnitude, the universe would be structureless. While we're in the cosmological neighborhood, we should put a few more dials on the table. The amplitude of primordial density fluctuations, often denoted Q, is roughly 10 to the power of 5. If Q were much smaller, matter would take too long to collapse into galaxies. Much larger, and the universe would be violently clumpy, with frequent black hole formations swallowing would-be habitats. Fold in the baryon-to-photon ratio, the electron-to-proton mass ratio, and the strengths of the fundamental forces, and you get a vector of parameters where the life-permitting region is a tiny Goldilocks island amid vast stretches of sterile possibilities. Again, the strength of the case is not one dramatic dial, but the conjunction. Galaxies, stars, stable nuclei, complex chemistry, a long, livable thermal environment, all of it co-orchestrated. Barnes's review runs through these with references to the astrophysical and particle physics literature. If you want to see the messy details, that's a good one-stop compendium. How does this bear on God, rather than simply on design in some thin sense? Here, the philosophy has to be as disciplined as the physics. If you simply declare design whenever something looks convenient, you're not doing science or philosophy. You're doing pattern matching. The Bayesian formulation disciplines the instinct. It forces you to ask, for each candidate hypothesis, what you should expect before peeking at the data. Theists argue that a God whose nature includes perfect knowledge and goodness has pro tanto reasons to create a world with finite rational agents and a theater for moral and aesthetic goods. Therefore, a life-permitting cosmos isn't a surprise. Naturalists who favor a single universe picture typically lack any comparable expectation builder. There is no reason within the hypothesis itself to anticipate life-permitting parameters rather than the dull, lifeless default. That asymmetry, expectation on one side, brute luck on the other, is the engine that turns fine-tuning into evidence. Now, one of the most sophisticated alternatives on offer is the multiverse. Maybe there's a vast ensemble of universes, each with different low-energy constants or symmetry breakings, perhaps generated by inflationary dynamics or by a string-theoretic landscape of vacua. In that case, even if the life-permitting region is minuscule, it's not surprising that somewhere in the totality conditions fall in that little window. And of course, observers will find themselves there rather than in the deserts. This is a serious research program, and it deserves serious engagement. But we have to keep two issues separate. First, does current physics require or even strongly support a multiverse that samples parameters in the way the explanation needs? That's a live technical debate. Second, even if it does, what's the prior credence for a reality that so obligingly generates the right distribution over constants? In other words, the Bayesian comparison doesn't disappear. It migrates up a level. Either way, Barnes's survey closes with the sober note that multiverse proposals face significant conceptual and empirical hurdles. The landscape might be there, but cashing it out in a way that actually populates life-permitting domains with non-negligible measure isn't trivial. There's a more subtle issue about selection effects that often gets misunderstood. People say, well, of course we find ourselves in a life-permitting universe. Where else could we be? That's true, but incomplete. Observation selection effects can tell you why you shouldn't be surprised to observe X, given that X had to obtain for you to exist, but they don't tell you why X obtains at all. In technical terms, they affect what conditional probability you should use when sampling from an ensemble. But unless there's an independently motivated mechanism that makes life-permitting regions sufficiently common, the existence of such regions remains surprising. A bare appeal to "we observe what we can observe" doesn't lessen the need for an explanation of why there are any such observationally possible niches in the first place. That's why so many careful expositions of the design argument argue in terms of confirmatory support rather than apodictic proof. You can grant the legitimacy of anthropic reasoning and still find that a theistic hypothesis gives you a more natural, less ad hoc account of why the ensemble contains fertile ground at all. Let me pull this out of the clouds with a simple analogy. Suppose you walk into a library where every book is printed in a script that matches your brain's processing patterns perfectly. Line length, font curvature, spacing, contrast, everything. If there are countless libraries with every possible scribble, then sure, somewhere there's one that fits you. And you couldn't be surprised to find yourself in it because you couldn't read elsewhere. But you'd still have a question. Why does the deeper mechanism generate libraries at all? And why with distributions that make readable ones even possible? If a hypothesis predicts that the generator will be value sensitive, say, aimed at creating beings who can understand, reason, and love, then readable libraries are to be expected. If a hypothesis predicts only undirected scribbles with no reason to anticipate readability, then readable books remain a surprise, and selection effects alone don't take away that surprise. At this point, it's natural to ask whether we're smuggling in theological assumptions to juice the probabilities. Here is where the intertraditional conversation is helpful. Christian, Jewish, and Islamic philosophies have long said that nature's orderliness is a sign, not a knockdown proof, but a resonance, of rational source. Aquinas's fifth way speaks in medieval idiom about goal-directedness in nature, while contemporary philosophers often translate that into probabilistic expectations. If there is a mind behind the order, then life and discoverability are the sorts of goods you'd antecedently expect. In fact, a modern twist due to Robin Collins explores not just fine-tuning for life, but fine-tuning for scientific discovery. The transparency of the world to mathematical description, the availability of stable information-rich wavelengths, and so forth. You can reject that extension, but the point is that the theistic hypothesis is specific enough to generate a family of expectations. It isn't a vacuous, whatever happens, God wanted it dodge. I also want to be honest about limits. Penrose's number 10 to the power of 10 to the power of 123 gets tossed around a lot. And you should beware of any argument that treats a big number as a magic talisman. Philosophically, the relevant question is comparative. What should we have expected before we opened the book of nature? Physically, the relevant question is explanatory. Will a future theory reduce some of the apparent arbitrariness by tying parameters to deeper symmetries or dynamics? Skeptics are right to warn against premature metaphysics here. Still, even careful technical discussions of initial entropy treat the extraordinary order of the early universe as something in need of explanation rather than something to shrug at. And in the meantime, it is epistemically responsible to go with the best comparison class you have. Given our live options, theism seems to make life-permitting order far less surprising than a brute single-universe naturalism does. A different kind of pushback says that many of these dials are interdependent, or that the life-permitting region might be wider if you allow exotic chemistries or novel biologies. Perhaps life unlike life as we know it, good. The argument shouldn't assume carbon chauvinism, but the more you loosen those constraints, the more you realize how many different tiers have to cooperate. Long-lived energy sources, information-bearing substrates, far from equilibrium environments, and stable complexity over cosmological timescales. This is why the fine-tuning case is cumulative. It's an orchestra, not a solo. Survey articles that try to expand the space of possibilities still come back to a shared conclusion. Even on liberal interpretations of life, the parameter space that permits any embodied, interacting, information-exploiting agents looks like a tiny island. Let's get a touch more technical about how the Bayesian version avoids a few common pitfalls. A naive presentation asks you to imagine every possible universe and then pick a measure. Basically, a rule that says how to weight the possibilities. And then it declares our universe improbable because the life-friendly region looks small. But measures over huge spaces can be ill-defined or arbitrary, and critics are right to object. So the defensible form of the argument doesn't start with cosmic metaphysics. It starts with the actual, well-posed models physicists use. Within each model, you can identify parameters, identify the life-permitting conditions within that model, and assess sensitivity with the model's own methods. Then you compare hypotheses by how naturally, or with how little special pleading, they make sense of the accumulation of such sensitivities. That move, keeping your probabilities tethered to real explanatory tasks, is how the best contemporary defenders avoid turning the argument into speculative numerology. Before we pivot to the theological upshot, I want to linger on one more concrete dial, because it illustrates the flavor of the whole case. Think about the amplitude of temperature fluctuations in the cosmic microwave background, the faint ripples that seeded galaxies. Those ripples reflect primordial density variations, and their amplitude has to be in that Goldilocks zone. Too small and structure never gels, too big and gravitational collapse runs roughshod over stability. From that one parameter, a story unfolds that touches everything from galaxy morphology to star formation rates to habitable planetary systems. When you lay those stories side by side with things like the Hoyle state and the cosmological constant, you don't just have one coincidental number, you have a network of independent requirements lining up. That's the moment where people's intuitions tend to shift. Not because any single figure makes design obvious, but because the overall pattern has the hallmark of intention. Many thresholds met simultaneously, rather than the hallmark of accident. No particular reason to expect that confluence? So what follows theologically? The fine-tuning argument, responsibly stated, doesn't leap from physics to a creed. It says instead, if the ultimate furniture of reality is mind-like, if value and reason are not aliens but natives here, then a life-friendly universe sits right where you'd expect it to sit. If reality is utterly indifferent at its root, then the fact that the dials happen to be set for life is astonishing. From there, different traditions bring their own resources. A Christian might read this as a scientific register for "let there be light," hearing in the intelligible order of nature an echo of logos, of word and wisdom through whom all things were made. A Muslim philosopher might hear in the same data an articulation of divine hikmah, wisdom and purposiveness in creation, that makes the world hospitable to Khalifa, stewardship. A Jewish thinker might tie it to the ancient confidence that the cosmos is tov meod, very good, ordered and therefore knowable under Torah's moral horizon. Secular philosophers might not assent to any of those narrative framings, but can still concede the comparative point about expectation and surprise. The case is cumulative. It mingles with arguments about why there is something rather than nothing, or why consciousness rides on matter the way it does, or why moral facts have the traction they seem to have. Fine-tuning doesn't carry the whole load. It adds weight to one side of the scale. Let me be clear about what would defeat, or at least seriously blunt, the argument. If future physics delivered a theory with no free parameters, elegantly deriving all constants and initial conditions from deep symmetries, And if the space of comparably simple theories overwhelmingly led to sterile worlds, then you'd still have a "why this theory" question, but the feel of contingency would soften. Or, if a well-motivated multiverse theory, anchored by testable implications in our domain, produced a measure over universes that made life-friendly pockets robustly expected without parameter fudging, then the elemental of astonishing luck would be mitigated. Proponents of design shouldn't fear those developments, they should welcome them, because truth matters more than our favorite arguments. As of today, though, on the publicly available balance of reasons, we still have strong grounds to say that a life-permitting universe is significantly more to be expected given theism than given a single universe naturalism. And at least as expected as given a speculative multiverse, especially when the latter's measure and testability puzzles are put squarely on the table. As we keep going, I want to make the argument maximally fair by walking around three critical neighborhoods. First, the charge that fine-tuning is an illusion, because life could adapt to whatever physics throws at it. Second, the worry that the whole argument is just God of the gaps dressed up in Bayesian clothing. And third, the claim that theism is so flexible it predicts any outcome, and thus predicts nothing. On the first, life is adaptable within a hospitable regime. But adaptability can't conjure stable nuclei or long-lived energy sources out of nothing. If chemistry is impossible, if all matter is unstable, if gravity never gathers or always crushes too fast, then no amount of Darwinian ingenuity gets you a biosphere. This is why the literature emphasizes preconditions, necessary conditions for any embodied, information-processing life, not the detailed biology of carbon-based organism. On the second, a gap is a receding island of ignorance where a non-theistic causal story is on deck but not yet complete. Fine-tuning isn't that. Fine-tuning rests on completed stories, stellar nucleosynthesis, structure, formation, and asks a meta-question about why those completed stories sit in a tiny life-friendly basin rather than in the generic, sterile region. That's not plugging God into a physics hole. That's asking why the physics lands in the productive region at all. On the third, if a view says, whatever happens, that's exactly what God wanted, then it's vacuous. But the mainstream theistic hypothesis is not that flabby. It asserts that God is perfectly rational and good, that conscious moral agents and their flourishing are significant goods, and that a law-governed, intelligible world is a fitting theater for such goods. Those claims have bite. They constrain expectations. When Robin Collins and others write for general audiences about the confirmatory version of the argument, they're trying to make that bite explicit. All right. Let's land this segment with one more image. Imagine you walk into a room and find a safe whose combination lock has 30 wheels, each with 100 digits. And by chance, the wheels just happen to be set to the one combination that opens the door. You could say, well, if they weren't set that way, I wouldn't be in the room to notice. True, but you're still entitled to ask whether there was a safecracker with a reason. The fine-tuning argument doesn't declare there must be a safecracker. It says only this. Given the options on the table, the safecracker hypothesis makes it far less surprising that the door is open. If, over the next decade, cosmology and particle physics hand us a perfectly natural mechanism that explains why the wheels land where they do, we'll file that under mechanism and ask the meta-question about why reality has that mechanism. If instead the best science continues to say lots of wheel settings are viable and the life-permitting ones are rare, and we have no deep reason to expect this one, then the evidential arrow toward mind will keep pointing where it points today. In the next stretch, I want to unpack how this line of thought has been received in contemporary analytic philosophy, with particular attention to distinctions between inference to the best explanation and Bayesian confirmation, and to case studies where theism and naturalism make different auxiliary predictions, like discoverability and the mathematical elegance of laws. We'll also press deeper into multiverse measures and the specter of so-called Boltzmann brains, because that's where many multiverse stories meet their strangest consequences. But for now, let me leave you with a handful of questions to sit with on your commute or your walk. If you bracket the rhetoric on all sides and simply ask what you should have expected before reading the book of nature, which worldview do you think better predicts a reality that produces knowers in a knowable world, and why? If you favor the multiverse, what specific mechanism do you think actually samples constants in the right way? And what evidence would count in your mind as a test of that mechanism's reality, rather than a speculative placeholder? How would your assessment change if a future theory elegantly derived today's free parameters? And would you still feel the pull of the question, why this elegant theory rather than the sterile neighbors? Is fine-tuning for discoverability, the fact that the world is unusually transparent to mathematical inquiry and rich in accessible information, something you would have expected a priori on your preferred worldview? Or does it strike you as an additional independent surprise? And finally, whatever you think of the metaphysics, what attitude does the sheer delicacy and fecundity of the cosmos call for in you? Gratitude, humility, urgency, or perhaps a sober resolve to keep following the evidence wherever it leads?